Okay, what we learned from the exploration and actually in chapter 2 was that similar figures must have all congruent angles. So if we're looking at triangles and we want to tell whether the triangles are similar, we have to first make sure and see that all of the angles are congruent. So in my first triangle, I see I have an angle of 75 and an angle of 50 and a missing angle. In the other triangle, I have an angle of 75 and 50 and a missing angle. What I should do first is figure out, well, what is my missing angle? If I add 75 and 50 together, that gives me 125. And then 180 degrees in a triangle minus 125 is 55. So this angle is 55. Okay, now if I look at my second triangle here, I have the same two angles. So that means if I were to add those together and subtract that from 180, I would end up with 55. And now I can see it in the first triangle I have an angle of 75, 50, and 55. In the second triangle I have an angle of 75, 50, and 55. So since all three angles are congruent, the triangles are similar. Now when I explain, I can say since all three angles are congruent, the triangles are similar, and this is the symbol for similar if you don't remember. Okay, now if we look at example B, in the first triangle I have an angle of 55, one of 63, and one of x. And in the second triangle I have an angle of 63, 63, and y. So what's different about this is in the first triangle I have a 54 and a 63, and in the second I have a 63 and a 63. So I really do need to figure out what is this missing angle. If I add together 54 and 63, that's 117. If I do 180 minus 117, that gives me 63. So x is 63, and maybe now that's enough information. If I look at my second triangle, I have an angle of 63 and 63, and a missing angle. If I look at the other triangle, the first one, I have an angle of 63, 63, and the last angle is 54. So this angle must also be the same as over here, 54. I can double check. If I add 63 and 63 together, that's 126. And if I do 180 minus 126, it's 54. So since all three angles are congruent, the triangles are similar. Okay, and here's a big conclusion at the bottom. If at least two angles in one triangle are congruent to two angles in another triangle, then the third angles are also congruent, and therefore the triangles are similar. So this is just saying if you're given two angles in one that are congruent to two angles in the other, then automatically you can say those triangles are similar without actually finding the third angle. Okay, I'm going to have you do the on your own, so push pause, tell whether the triangles are similar, explain, and then when you're ready, push play. Okay, for the first example, you see that when you found your angles in the top triangle, you have an angle of 80, 72, and 28, and in the bottom triangle, you have an angle of 81, 71, and 28. So these two triangles are not similar because they don't have at least two angles that are congruent. So I can say the triangles are not similar because there are not three congruent angles. In the second one, I noticed that this angle was 90, so then my missing angle was 24, and then I stopped because I noticed there was enough information to say they were similar. In the first triangle, then I have an angle of 90, an angle of 24, and in the bottom triangle, I have an angle of 90, and an angle of 24, so automatically this last one has to be 66. So for my explanation I can say since two angles are congruent, the third angles are also congruent, and therefore the triangles are similar. Okay, on the back side, we are trying to use similar triangles to figure out missing measurements. So for the flags one, it says how tall is the taller flagpole. We want to figure out how tall it is here. There's a couple ways you can do this. Yesterday you used scale factor. So you looked at two of the corresponding sides, so the shadow of both of these flags here. To get from 2 to 6, you need to figure out what the scale factor is. Well, 2 times 3 is 6, so you use the same scale factor up here. 7 times 3 is 21. The other way would have been to set up a proportion with two ratios. And remember, you always use what you're looking for first. So h, the height over its shadow, which is 6. And then for the smaller flag, the height was 7 over its shadow, which was 2. And so we could undo the equation this way. Multiply by 6 on both sides. So on this side I have 7 times 6, which is 42. And then 6 over 1. 2 times 1 is 2. So the height is 42 over 2. 42 divided by 2 is 21. So the height is 21 feet. On the second one, it's a little bit trickier because now you're trying to figure out 12.5 times what is 50. Okay, this one I suggest if you aren't good with figuring out scale factor, then you would set up a proportion. So the height over its shadow, which is 50, equals the height of the smaller building, 50, over its shadow, which is 12.5. Okay, so I'll undo this by multiplying by 50 over 1 on both sides. 50 times 50 is 2,500, and 12.5 times 1 is 12.5. To simplify this, 2,500 divided by 12.5 is 200. I'll write that out here. 2,500 divided by 12.5 equals 200. So that's 200 feet. Okay, now we're going to use similar triangles again to figure out how you're going to cross a river. So you plan to cross a river and want to know how far it is to the other side. You take measurements on your side of the river and make a drawing as shown. So first of all, we have to look here. We've got two similar triangles. I have one with 40 feet for its base and 50 feet for its height, and the other one with 30 feet for its base and x for its height. So it might actually help to draw out these two triangles, 50 for the height, 40 for the base, and for the smaller triangle, I have x for the height and 30 for the base. Okay, since we know these were right angles, we need one more angle to mark so we know these two triangles are congruent. If you look in the middle here, those are vertical angles, so those are congruent. So I can now go mark those on my triangle. So when I explain why they're similar, I can say since angle BCA, which is this one, and angle ECD, which is this one, are vertical, they are congruent. This means the triangles have two congruent angles, which makes them similar. Because remember, all we need are two congruent angles because automatically the third angle is congruent. Okay, so for B, what is the distance across the river? You can either use scale factor or you can set up a proportion. I'm going to set up a proportion, so I'm going to take what I'm looking for, the height of x over its base, which is 30. And in my second triangle, the height was 50 over the base, which was 40. I'll multiply by 30 on both sides, 30 over 1. These cancel. Okay, 50 times 30 is 1,500. 40 times 1 is 40. When I simplify that, it's 1,500 divided by 40, which is 37.5 feet. This one is where it's a little bit more difficult to use scale factor because you don't have a nice whole number. So that right there is 37.5 feet, or the distance across the river, 37.5 feet. Okay, and last one here. Same idea. You want to cross the river, you want to know how far it is to the other side. You take measurements on your side of the river and make the drawing shown. So you are right over here, and you know it's 60 feet to the bank of the river, and then 90 feet down, and you want to know how far across this is. So first, explain why ABC and DEC are similar. Remember we said they have two congruent angles because of the vertical angles. So for part A, the vertical angles are congruent, and so are the perpendicular. Which makes both triangles have two congruent angles, so they are similar. For part B now, what is the distance across the river? So here's where I'm going to break apart my triangles. I'm going to draw the larger one with a height of 60 and a base of 50, and the smaller one is upside down. So if you look here, the base is actually 50. There's my base. There's my base. And here's my height. And here's my height. So the smaller one has a base of 40 and a height of x. Okay, I'm going to make a ratio. So height over base over 40 equals, in my other triangle, I have a height of 60 over my base, which is 50. Okay, some of you are used to probably cross multiplying and dividing. You can do that. That works for you. I'm going to multiply by 40 over 1 on both sides. So 60 times 40 is 2,400 divided by 50, and 2,400 divided by 50 is 48. So the height equals 48 feet, and it's actually 48 feet across the river. It's really not 48 feet tall.
Okay, we're going to look at a few more examples here that makes finding missing side lengths of similar figures very easy, and that's by solving a proportion. So what we have set up here is a proportion. A proportion is just two ratios that are set equal to each other, and we have a missing, could be a length, but a missing value here for the a ratio that we need to figure out what x is equal to. So one very easy way to solve is by cross multiplying. So I'm going to walk you through that for example 1. So in example 1, the first thing I look at is the two given numbers, and I do 7 times 3, which I know is 21. Okay, and then I look at the other two numbers, 5 and x. 5 times x is 5x. So then I have an equation written. Okay, now I just have to solve for x in my equation, which this is a one-step equation. 5 times x, to undo that, I need to divide both sides by 5. And when I divide 5 by 5, that's a 1, and 21 divided by 5 is 4.2. So I can see that the missing value for x is 4.2. Okay, now if I look at the next one on example 2, I'm going to look at the two numbers that I've been given and multiply those across from each other. Diagonal, 14 times 15 is 210. And then I look at 6 times x, which is 6x. And there's my one-step equation. So to undo 6 times x, I'm going to divide both sides by 6. And 210 divided by 6 is 35. So the missing value for x is 35.